A lone voyager drifts through the sprawling golden meadows of the Milky Way, a silent witness to a celestial architecture that spans over 100,000 light-years of shimmering emptiness. Here, in the far-flung suburbs of the galactic disk, the stars are scattered like embers from a dying fire, separated by vast, lonely gulfs of vacuum. The suns of the outer rim move with a stately ancient grace, their orbits so wide and their paces so measured that time itself seems to hold its breath. These reaches are dominated by veils of ancient dust, towering nebulae that glow with the soft nursery light of newborn stars and the cold, dark silhouettes of molecular clouds that mask the brilliance of the galactic interior. To move inward is to leave behind the quiet solitude of the spiral arms and enter a realm where the very density of existence begins to thicken, pressing inward with the weight of 100 billion suns. As the journey progresses toward the heart of the galaxy, the serene, slow-motion waltz of the periphery begins to dissolve. The gaps between the stars shrink from light years to light months, then light weeks, until the sky is no longer a dark tapestry punctuated by lonely pinpricks of light, but a blinding, crowded ballroom of fire. The colours shift from the cool reds and yellows of the outer reaches to the fierce electric blues of massive stars that burn fast and die young. The motion of these celestial bodies undergoes a profound transformation. The predictable, linear paths of the galactic disk are replaced by a frantic, high-speed choreography. This is the inner sanctum, a place where the laws of cosmic motion are pushed to their absolute breaking point. Stars do not merely drift here, they scream through the void, whipped into a frenzied dance by an influence that remains hidden from the naked eye. At the very centre of this swirling tempest lies a point of absolute terrifying stillness. It is the eye of the hurricane, a region where the frantic motion of the surrounding stars reaches a fever pitch before surrendering to a silence that defies the logic of the material world. We find ourselves standing on the edge of a precipice where space and time no longer behave like the familiar rigid fabric of our daily lives. Instead, the geometry of the universe begins to warp and buckle, behaving like a fluid medium that has lost its internal strength. Space-time flows toward this central point like a waterfall cascading into an infinite void, a river of reality that accelerates as it nears the brink, eventually plunging over an edge from which no signal, no light, and no memory can ever return. This central point is not a place of light, but a shadow cast against the brilliance of the galactic core. It is the heart of the Milky Way, the anchor around which the entire galaxy rotates, yet it possesses no surface, no substance, and no reflection. A monster sleeps here in the shadows, holding the fate of an entire galaxy in its invisible, unyielding grip. This titan possesses the mass of 4 million suns, compressed into a volume so small that it effectively vanishes from the physical map of the universe, leaving behind only the ghost of its gravity. This is Sagittarius A star, a supermassive black hole that acts as both the progenitor and the potential executioner of the world we inhabit. The presence of this monster is the fundamental truth of our galactic home. It is the invisible hand that guides the rotation of the stars, the heavy weight that prevents the Milky Way from flying apart into the dark reaches of intergalactic space. Every star, every planet, and every living soul on the pale blue dot of Earth is tethered to this dark sun by a thread of gravity that stretches across 26,000 light years. The reality of this abyss is not merely a scientific curiosity or a mathematical abstraction. It is a testament to the fragile beauty of existence teetering on the brink of non-existence. The monster does not need to hunt to exert its power. Its mere existence bends the light of a billion stars and dictates the flow of time itself. As we peer into this central darkness, we are forced to confront the limits of our understanding. The waterfall of space-time carries everything toward a singularity, a point where the density becomes infinite, and the laws of physics, as we have written them, cease to function. In this region, the future and the past are compressed into a single, agonizing moment of transition. The stars that venture too close are not merely consumed, they are disassembled, their matter stretched into glowing ribbons of plasma that orbit the void in a final, desperate plea for survival. This is the governance of the abyss, a regime of gravity so absolute that it defines the very architecture of the heavens. The sleeping monster at the center of the map is a reminder of the scale of the cosmos and our place within it. We live in the quiet wake of this titan, oblivious to the violence and the majesty of the core. Yet the fate of the Milky Way is inextricably linked to the behavior of this central shadow. Should the monster wake from its long slumber and begin to feed in earnest, the resulting eruption of energy would transform the galaxy from a peaceful spiral into a blazing quasar, a beacon of radiation that would be visible across the entire observable universe. For now, however, the Titan remains quiet, a silent guardian of the mystery that lies at the heart of all things. The journey into the centre is a journey toward the ultimate boundary of knowledge, a place where the light of 100 billion suns finally meets the eternal, unyielding dark. For the vast majority of our species' existence, the night sky was perceived as a static and silent gallery, a fixed arrangement of lights that spoke of a clockwork universe. We looked upward and saw a peaceful order, never suspecting that a dragon guarded the inner sanctum of our world. This long era of optical innocence began to fracture in the 1930s, not through the lens of a telescope, but through the crackle of a radio receiver. A young engineer named Karl Jansky, working for Bell Telephone Laboratories, was tasked with identifying the sources of static that plagued long-range communication. He constructed a strange, rotating skeletal structure of wood and wire, a contraption that moved on the wheels of a Ford Model T, designed to sweep the horizon for interference. What he discovered was a ghost in the static, a persistent and rhythmic hiss that defied every known terrestrial explanation. This signal did not follow the sun, it followed the stars. It reached its peak intensity every 23 hours and 56 minutes, matching the exact rotation of the Earth relative to the distant heavens. The hiss was a whisper from the direction of the constellation Sagittarius, a voice from the very heart of the Milky Way that had been travelling for 26,000 years to reach the antenna of a man who was not even looking for it. At the time, the scientific community was ill-equipped to hear what the universe was saying. The heavens were supposed to be a vacuum of silence, yet here was a signal that suggested the core of our galaxy was not a place of quiet repose, but a site of profound and energetic activity. It was the first hint that the map of the heavens we had drawn with light was incomplete, and that a much darker, more powerful reality was hidden behind the veils of dust. The mystery deepened in the 1970s when astronomers Bruce Ballack and Robert Brown turned the burgeoning power of radio interferometry toward that same coordinate in the southern sky. They discovered a source of radio waves that was incredibly compact, yet possessed an intensity that defied the logic of stellar physics. To name this anomaly, they settled on a designation that felt like a mathematical scar on the map of the heavens, Sagittarius A star. The asterisk, a symbol borrowed from the language of atomic physics to denote an excited state, was appended to the name like a warning. It marked a spot where the known laws of the universe seemed to vibrate with a strange, unnatural energy. This was not a star in any traditional sense. It was a point of departure, a place where the physical world seemed to fray at the edges. Despite this evidence, the ivory tower of the scientific establishment remained haunted by denial. For decades, the concept of a supermassive black hole was dismissed as a mathematical phantom, a theoretical curiosity born from the extreme solutions to Einstein's equations rather than a physical reality that could actually exist in the vacuum of space. The idea that millions of suns could be crushed into a single point of zero volume was offensive to the sensibilities of those who preferred a universe of elegant Newtonian clockwork. Critics argued that such singularities were merely failures of the mathematics, glitches in the human attempt to describe the infinite. They preferred to believe in dense clusters of dark stars or exotic clouds of heavy particles, anything to avoid the terrifying implication of a hole in the fabric of reality itself. To prove the existence of the monster, humanity had to stop looking for light and start watching the shadows. The struggle to see the invisible required a fundamental shift in perspective. If the object at the center could not be seen, then its presence must be inferred by the havoc it wreaked upon its neighbours. Astronomers began to focus their gaze on the stars that inhabited the innermost parsecs of the galaxy, a cluster of high-mass suns that should have been moving with the measured pace of a crowded stellar neighbourhood. Instead, they found a scene of cosmic desperation. These stars were being whipped around an empty point in space, at velocities reaching several % of the speed of light. They moved like moths caught in a localized gale, tracing tight, elliptical orbits around a hidden hand that possessed an iron grip. This hidden hand was the only explanation left. No cluster of stars, no matter how dense, could occupy such a small volume, without collapsing under its own weight or being visible to our instruments. The data began to paint a picture of a Titan that was 4 million times heavier than our Sun, yet smaller than the orbit of Mercury. It was a weight that anchored the entire rotation of the Milky Way, a silent governor that dictated the paths of 100 billion suns. The transition from skepticism to acceptance was not a sudden revelation, but a slow, agonizing surrender to the evidence of motion. We realized that the center of our home was not a sanctuary of light, but a throne for a king that consumed everything it touched. The ghost at the center of the map had finally taken on a terrifying physical weight, and the peaceful arrangement of the night sky was forever revealed to be the mask of a much more violent and beautiful truth. The anatomy of this abyss begins at the event horizon, a threshold that marks the absolute limit of the observable universe. It is not a surface composed of stone, gas, or liquid, but a boundary of pure geometry, a point of no return where the escape velocity required to flee the dark exceeds the speed of light. At this perimeter, the very concept of an outward direction ceases to exist. To cross this line is to enter a region where the laws of causality are rewritten by the sheer weight of a 4 million solar mass Titan. Here, the fabric of space-time does not sit still as a static stage for the drama of the stars. Instead, it behaves like a fluid medium, a cosmic river that flows with increasing ferocity toward the center. It is a waterfall of reality itself, a cascading torrent of space rushing toward a drain that has no bottom. As one approaches this invisible brink, the distortion of the cosmos becomes total. Light from the outside world is caught in the gravitational tide, bent into a halo of tortured photons that circle the abyss in a desperate circular orbit. But for anything that crosses the horizon, the geometry of the universe undergoes a radical and terrifying inversion. In the world we inhabit, we are free to move left or right, up or down, or forward and backward in space, yet we remain prisoners of a single direction in time, always marching toward the future. Inside the event horizon, these roles are swapped. The radial direction toward the center of the black hole becomes the new temporal axis. Every movement, every heartbeat, and every desperate attempt to turn back only carries the traveller closer to the central singularity. To move toward the center is no longer a choice of navigation. It is the inevitable passage of time itself. One can no more turn away from the center than a mortal can turn away from the arrival of tomorrow. The singularity is not a point in space, but a point in time, an unavoidable future that waits at the end of every possible path. The physical experience of this journey is one of supreme, agonizing transformation. As an object descends, it encounters the phenomenon of spaghettification, a term that belies the sheer violence of the process. Gravity is not a uniform pull, it is a gradient that grows exponentially steeper with every millimetre of descent. If a traveller were to fall feet first into the dark, the gravitational influence exerted upon their toes would be vastly superior to the force acting upon their head. This tidal disparity acts as a cosmic rack, stretching the body with a relentless tidal hunger. Flesh and bone are the first to surrender, followed by the very molecules that comprise them. The bonds that hold atoms together are overcome by the sheer curvature of space, rending the traveller into ribbons of subatomic particles, a stream of light and matter that is elongated into a thin glowing thread. This is the cruel reality of the abyss. It does not merely consume, it deconstructs. The matter that once formed stars, planets, or people is reduced to its most basic components, stripped of all identity and history. These ribbons of light are pulled into the central void, joining the vast invisible mass that anchors the galaxy. The process is a testament to the absolute power of gravity when it is allowed to reach its logical conclusion. In the heart of the Milky Way, this engine of destruction operates with a precision that leaves no room for error. There is no resistance possible against a force that has hijacked the very flow of time. The traveller becomes part of the black hole, their mass added to the total weight of the monster, their story ending in a final silent integration into the dark. Beyond the horizon, the light of the entire universe seems to gather in a final, brilliant flash before it is extinguished. The traveller, now reduced to a stream of plasma, witnesses the history of the cosmos accelerated and distorted, a cinematic finale to a journey that ends in a point of infinite density. This central singularity is the ultimate destination of the waterfall, a place where the mathematical descriptions of our world break down into nonsense. It is a point where the curvature of space becomes infinite, and the volume of the monster becomes zero. Here, the ribbons of light are crushed into a state of existence that defies human language, a final silence that marks the end of the line for everything that has ever fallen into the grip of Sagittarius A star. The architecture of the abyss is thus revealed as a bridge to nowhere, a structure built of gravity and time that leads only to the ultimate dissolution of the self into the dark heart of the home we share. Yet, before this final plunge, the material gathered by the monster is subjected to a different kind of torment. It is caught in the accretion disk, a ring of fire that serves as the most efficient furnace in the cosmos. Here, the ribbons of light are joined by vast clouds of gas and dust, all swirling at a significant fraction of the speed of light. The friction between these particles, compressed by the immense gravity, generates temperatures of millions of degrees, creating a glow that can be seen across the vastness of the intergalactic void. Through this lens, the black hole is revealed not as a passive consumer, but as an active, screaming engine of transformation, a place where the very essence of the universe is turned inside out, converting the solid matter of the stars into raw, radiant energy that screams into the night. Before the final plunge into the unyielding dark, matter is caught in a ring of fire that outshines the collective brilliance of thousands of suns. This is the accretion disk, a swirling, feverish halo of tortured gas and dust that serves as the most efficient engine in the known universe. Here, the kinetic energy of motion is transformed into a radiant fury through the simple, brutal mechanism of friction. As the material spirals inward, drawn by the irresistible pull of the central titan, it is compressed and heated to temperatures reaching millions of degrees. The particles within this disk collide with such violence that they are stripped of their electrons, becoming a screaming plasma that vibrates with the energy of 1 billion lightning strikes. This disk is not merely a passive byproduct of the black hole's hunger. It is a cosmic furnace where the very substance of reality is ground into light. The efficiency of this gravitational engine is unparalleled. In the heart of a typical star, nuclear fusion converts less than 1% of the available mass into energy. By contrast, the accretion disk around a supermassive black hole can convert nearly 40% of the mass of an incoming object into pure, unadulterated radiation. This is the ultimate expression of the most famous equation in physics, where mass and energy are revealed as two sides of the same coin, traded with a terrifying precision that leaves no room for waste. Every gas cloud, every stray planet, and every unlucky star that ventures too close to the event horizon is subjected to this process of total conversion. The resulting light is so intense that it can be detected across the vast reaches of the intergalactic void, a beacon of energy that signals the presence of a monster lurking in the dark. At the center of this radiant storm sits the Titan itself, a weight equivalent to 4 million solar masses. This is a number that defies human comprehension, representing the mass of 4 million suns crushed into a region of space smaller than the distance between our own sun and the planet Mercury. This immense weight provides the gravitational anchor for our entire galactic neighborhood. The rotation of the Milky Way, with its hundreds of billions of stars and its sprawling spiral arms, is fundamentally dictated by the presence of this central shadow. Without this anchor, the stars of the core would fly apart, and the elegant structure of the galaxy would dissolve into a chaotic cloud of wandering suns. The black hole is the master architect of the heavens, the silent governor whose invisible grip maintains the order of the cosmos. The relationship between Sagittarius A star and the surrounding galaxy is a delicate and complex balance of power, a governance of shadows that dictates the life and death of the stars. This interaction is defined by a process known as feedback, a cosmic thermostat that regulates the growth of the galaxy itself. When the black hole feeds, the accretion disk erupts with radiation and powerful jets of subatomic particles that scream outward at nearly the speed of light. This outpouring of energy exerts a profound pressure on the surrounding clouds of cold molecular gas, the very nurseries where new stars are born. If the black hole becomes too active, the heat and radiation it emits can blow these gas clouds away, effectively halting the birth of new stars and sentencing the galaxy to a slow, quiet decline. Conversely, if the black hole remains dormant for too long, the gas in the galactic core can cool and collapse, triggering a burst of star formation that consumes the available fuel with reckless abandon. The monster at the centre thus acts as a regulator, ensuring that the galaxy does not grow too fast or burn out too quickly. It is a relationship of mutual dependence. The galaxy feeds the black hole, and the black hole in turn shapes the evolution of the galaxy. This governance is not one of benevolence, but of cold, physical necessity. The Titan does not care for the stars that orbit it, yet its every action determines their fate. It is the sculptor of the heavens, carving the destiny of the Milky Way out of the raw material of the void. This balance of power is what has allowed our own solar system to exist in a state of relative peace for billions of years. We reside in the quiet suburbs, far from the screaming energy of the accretion disk and the tidal fury of the core. Yet, we are not separate from it. The light we see from the stars and the very stability of our orbit are part of the grand architecture maintained by the monster in the dark. To understand the accretion disk is to understand the true nature of power in the universe, not as a force of destruction, but as a force of transformation. The black hole takes the cold, silent matter of the void and turns it into a radiant display of energy that defines the limits of what is possible. It is a reminder that in the cosmos, even the most profound darkness is surrounded by a ring of light, a testament to the enduring power of gravity to shape the story of existence. Among the dense cluster of suns that inhabit the innermost parsecs of the galaxy, one star stands out as a primary witness to the absolute power of the abyss. This is S2, a massive blue sun that serves as a celestial moth fluttering around a gravitational flame. For decades, astronomers have tracked its journey as it completes a treacherous elliptical orbit that brings it closer to the central monster than almost any other known star. At the furthest point of its path, it drifts through the crowded stellar neighbourhood with a deceptive calm. But as it begins its long fall toward the centre, the invisible grip of Sagittarius A star takes hold. The star accelerates to velocities that defy the traditional logic of celestial mechanics, reaching speeds of 7,600 kilometers per second at its closest approach. This is nearly 3% of the speed of light, a velocity required simply to avoid being swallowed by the void and to maintain its precarious balance on the edge of the precipice. This star is more than just a distant light. It is a physical laboratory that reveals the deep geometry of the universe. As S2 swings through its pericenter, only 17 light hours away from the event horizon, it passes through a region where space and time are warped into a profound curve. The path it follows is not a perfect repeating ellipse, as described by the ancient laws of planetary motion, but a shifting, rotating trajectory known as a Schwarzschild precession. Every 16 years, as the star completes its circuit, the orientation of its orbit changes slightly, tracing a flower-like pattern in the dark. This subtle shift is a direct confirmation of the predictions made by Albert Einstein on a chalkboard over 100 years ago. It proves that gravity is not a force acting at a distance, but the result of matter bending the very fabric of reality. The light from S2 even loses energy as it struggles to climb out of the gravitational well of the black hole, shifting toward the red end of the spectrum in a phenomenon known as gravitational redshift, a final, glowing testament to the Titan's influence. The relationship between the black hole and the stars like S2 is part of a larger, more complex system of cosmic governance. The monster at the centre is a sculptor of the heavens, acting as a regulator for the entire galactic core through a process of energetic feedback. While it possesses the power to consume everything in its vicinity, it often spends eons in a state of quiet starvation. In this dormant phase, it is a picky eater, allowing the vast majority of the gas and dust that surrounds it to drift by unmolested. However, the small amount of matter that does fall into the accretion disk is enough to generate a steady stream of radiation that heats the surrounding interstellar medium. This heat prevents the gas from cooling and collapsing into new stars, effectively capping the population of the inner galaxy. By heating its environment, the black hole ensures that the core does not become so densely packed with suns that the entire system becomes unstable. This state of quiet starvation is the current reality for Sagittarius A star. Compared to the blazing quasars found in the hearts of distant younger galaxies, our central monster is remarkably dim, consuming only a tiny fraction of a solar mass every year. It flickers with occasional flares of infrared and X-ray light, the equivalent of cosmic crumbs falling from a table. Yet, this lethargy is temporary. The monster waits with the patience of a predator for a stray gas cloud or a wandering star to venture too close. When such a meal arrives, the quiet starvation ends in a feast of light. We have observed clouds of gas, such as the one designated G2, being stretched and torn as they pass near the event horizon, their outer layers stripped away to join the glowing carousel of the accretion disk. If a full-size star were to wander into the tidal radius of the black hole, the result would be a tidal disruption event, a cataclysmic feast that would release more energy in a few months than our Sun will emit in its entire 10 billion-year lifetime. The star would be rent asunder, its gases spiralling into the abyss and creating a flare of radiation that would illuminate the entire Milky Way. This potential for violence is always present, hidden behind the mask of the monster's current inactivity. The black hole is the ultimate arbiter of the galactic core, a silent presence that dictates when stars may be born and when they must die. It maintains the delicate balance of the heavens, ensuring that the galaxy remains a stable, structured home for the hundreds of billions of stars that orbit its dark heart. Through the eyes of S2, we see the true nature of this governance, a world of extreme speed and warped geometry, where the destiny of every sun is written in the shadows of the Titan. The current tranquility of the Milky Way is a fragile mask, a temporary reprieve in a cycle of violence that spans billions of years. Should a massive influx of matter, perhaps a large molecular cloud or a cluster of stars, fall into the gravitational well of the centre, the sleeping Titan would undergo a terrifying metamorphosis. The quiet hiss of radio waves would be replaced by a roar of radiation across every frequency of the electromagnetic spectrum. This is the birth of a quasar, a quasi-stellar radio source that transforms the galactic core into the brightest object in the observable universe. In this state, the accretion disk becomes a maelstrom of white-hot plasma, glowing with the intensity of 1 trillion suns. The energy released by the consumption of just a few solar masses per year is enough to outshine the entire combined light of the hundreds of billions of stars that form the rest of the galaxy. As the monster gorges itself, the immense magnetic fields generated by the spinning disk would twist into tight vertical spirals, acting as a cosmic cannon. From the poles of the black hole, twin jets of relativistic particles would erupt, screaming into the void at nearly the speed of light. These jets would not be confined to the local neighbourhood. They would pierce through the galactic disk and extend for tens of thousands of light years into the intergalactic medium. They would act as thermal blowtorches, heating the gas in their path to millions of degrees and carving vast cavities in the interstellar medium. The sheer scale of this eruption would redefine the architecture of the galaxy, creating a beacon of light and energy that could be seen by civilizations in galaxies millions of light-years away. For the stars and planetary systems unlucky enough to reside near the core, the awakening of the monster would be an ending. The flood of X-rays and gamma radiation from the accretion disk would be so intense that it would strip away the atmospheres of any nearby worlds, sterilizing the surfaces of planets and bathing the heavens in a lethal invisible fire. the galactic center would become a wasteland of radiation, a place where the delicate chemical bonds required for life are shattered by the relentless bombardment of high-energy photons. In this scenario, the black hole reveals its role as the ultimate executioner, a force of nature that can erase the potential for life across thousands of cubic light-years in a mere geological heartbeat. It is only because our solar system resides in the quiet, dusty suburbs, 26,000 light-years away from this central furnace, that we have been granted the stability required for life to evolve. We live in a rare window of cosmic silence, a time when the monster is dormant and the radiation levels are low enough for biological chemistry to flourish on a tiny blue rock. Our position in the galactic disk, tucked away in the Orion Arm, provides a shield of distance and dust that protects us from the occasional flares and flickers of the core. The current piece of our sky, where the stars move in predictable, silent orbits, is a direct result of the Titan's long fast. We are the beneficiaries of its hunger being sated by nothing more than the occasional wisp of gas. In this light, the black hole is revealed as a dual entity, both the protector that anchors our home and the executioner that could one day destroy it. Its gravity holds the galaxy together, preventing the stars from drifting into the lonely dark of the intergalactic void, yet its appetite represents a constant, existential threat. The history of the Milky Way is a story of this balance, a long-running tension between the creative force of gravity and the destructive power of radiation. We exist because the monster is sleeping, a fact that highlights the precarious nature of our place in the universe. The peace we enjoy is not a guarantee, but a temporary condition dictated by the flow of matter in a region of space far beyond our reach. The Titan remains at the heart of our world, a silent, heavy presence that could, at any moment, wake and reclaim the light it has so far allowed to shine. This dormant state is not merely a lack of activity, but a period of accumulation. Even now, the gravitational reach of Sagittarius A star is drawing in the surrounding material, preparing for a future feast. The structures we see in our galaxy, such as the Fermi bubbles, vast lobes of gamma-ray emitting gas that extend above and below the galactic plane, are the scars of previous awakenings. They tell a story of a monster that has woken before and will surely wake again. The cycle of the quasar is the heartbeat of the galaxy, a slow and powerful rhythm that spans millions of years. We are currently living in the quiet space between beats, a moment of grace that has allowed for the rise of consciousness and the ability to look back at the source of our own stability with a mixture of awe and terror. The contrast between the violent potential of the core and the serene orbits of our neighborhood is the defining characteristic of the Milky Way. It is a world of extremes, where the most profound darkness is the source of the most intense light. As we watch the stars of the core dance around the invisible Titan, we are seeing the machinery of the universe at its most fundamental level. The black hole is the engine of the galaxy, a machine that converts the raw matter of the cosmos into the energy and structure that define our existence. Whether it acts as a protector or an executioner is a matter of scale and time, a reminder that in the grand narrative of the universe, we are but a brief and flickering spark in the shadow of an eternal flame. The verification of this central Titan was not the result of a single moment of revelation, but the fruit of a decades-long quest undertaken by two relentless pioneers of science, Andrea Ghez and Reinhard Genzel. Their journey began in the 1990s, a time when the heart of the Milky Way remained hidden behind thick, suffocating curtains of interstellar dust that blocked almost all visible light. To peer through this veil, they could not rely on traditional telescopes. They had to look in the infrared, a part of the spectrum where the heat of distant stars can slip through the gaps between dust grains like ghosts through a wall. This was a task that required the world's largest and most sophisticated instruments, located on the high, lonely peaks of Mauna Kea in Hawaii and the desolate Atacama Desert in Chile. For over 20 years, these two scientists and their competing teams watched the galactic center with the unwavering patience of monks. They were not looking for the black hole itself, which remained stubbornly invisible, but for the stars that inhabited its immediate vicinity. This was a feat of observational endurance that pushed the limits of human technology. The primary obstacle was the Earth's own atmosphere, a turbulent sea of air that distorts the light from distant suns, causing them to blur and shimmer. To the naked eye or even a standard telescope, the crowded centre of the galaxy appeared as a smudged, indistinct glow. To overcome this, Gez and Genzel utilised a technological triumph known as adaptive optics. This system uses powerful lasers to create an artificial guide star in the upper atmosphere, allowing a computer to measure the atmospheric distortion hundreds of times every second. In response, small, deformable mirrors within the telescope flex and shift, counteracting the blur and sharpening the image of the heavens to a degree that was previously thought impossible. With this newfound clarity, the scientists began to track the movements of individual stars, specifically a group of high-velocity suns known as the S-stars. Year after year, they recorded the positions of these celestial bodies with agonizing precision. They watched as the star known as S2 completed its long elliptical journey, diving toward the invisible center and then being flung back out into the stellar neighborhood at several % of the speed of light. The tension of the hunt was palpable. Every new data point was a piece of a cosmic puzzle that had remained unsolved for generations. As the years turned into decades, the orbits of these stars were traced with such accuracy that the mass of the object they were circling could no longer be a matter of speculation. The realization was as profound as it was terrifying. The mathematical models fed by the tireless observations from the Keck Observatory and the Very Large Telescope pointed to a single, inescapable conclusion. There was an object at the centre of the Milky Way that possessed the mass of 4 million suns, yet it occupied a volume of space no larger than our own solar system. It emitted no light of its own, yet it held the most massive stars in the galaxy in a tight, frantic embrace. The invisible ghost that Karl Jansky had heard whispering in the 1930s and that Balick and Brown had named in the 1970s had finally been weighed and measured. It was a supermassive black hole, a physical reality that defied every common-sense intuition about the nature of the world. This discovery was a watershed moment in the history of astronomy, a triumph of the human spirit over the vastness and obscurity of the cosmos. It proved that the most extreme predictions of general relativity were not just elegant equations on a chalkboard, but the actual blueprints of the universe. The dedication of Gez and Genzel, their willingness to spend a significant portion of their lives staring into the dark, eventually earned them the highest honours in science, including a share of the Nobel Prize in Physics in the year 2020. Their work transformed the study of black holes from a theoretical niche into a cornerstone of modern astrophysics, providing the first definitive proof that these monsters are not just possible, but are the fundamental anchors of the galaxies we call home. Yet, even as the existence of Sagittarius A star was confirmed, a new and even more ambitious challenge emerged. The scientific community was no longer content with merely watching the stars dance around the shadow. They wanted to see the shadow itself. They sought to capture an image of the event horizon, the very edge of the abyss where light is lost forever. This would require a telescope not of metal and glass, but of global cooperation and digital synthesis. The quest to pierce the veil had reached its climax, but the final act of visualization was only just beginning. The monster had been found, its weight was known, and its influence was mapped. Now, for the first time in the history of our species, we prepared to look directly into the eye of the titan that governs our world. To see the unseeable, humanity had to build a mirror as wide as the world itself. The quest to resolve the tiny shadow of Sagittarius A star from a distance of 26,000 light-years is an undertaking equivalent to standing in New York and attempting to photograph a single orange sitting on the surface of the moon. No single dish on Earth possessed the diameter necessary to capture such a minute detail, for the laws of physics dictate that the clarity of an image is limited by the size of the aperture. To overcome this barrier, a global team of scientists forged the Event Horizon Telescope, a virtual instrument created by linking radio observatories across the entire planet. This network utilized a technique known as very long baseline interferometry, effectively transforming the Earth itself into a single massive eye and turning the rotation of the world into a tool for scanning the heavens. The project required the seamless synchronization of 8 observatories scattered from the frozen crystalline wastes of the South Pole to the high, arid deserts of Chile, and from the volcanic peaks of Hawaii to the rugged mountains of Spain and Arizona. Each site was equipped with hydrogen mass or atomic clocks, devices so precise they lose only 1 second every 100 million years. These clocks allowed the telescopes to record the arrival of radio waves with a timing accuracy of a fraction of a billionth of a second, ensuring that the signals from each far-flung location could be perfectly aligned. The data collected was so vast, reaching thousands of terabytes, that it could not be sent over the internet. Instead, hundreds of hard drives had to be physically flown to central processing hubs in the United States and Germany, where supercomputers spent years stitching the fragments of the signal into a coherent whole. In the spring of 2017, the global eye turned toward the center of the Milky Way. For 5 nights, the weather across the planet held steady, allowing the network to capture the faint, millimeter wavelength whispers of the galactic core. The challenge was not to take a photograph in the traditional sense, but to create a map of the silhouette of gravity. Because the black hole itself emits no light, it appears as a dark void, a shadow cast against the brilliant backdrop of the surrounding accretion disk. The light captured in the resulting image is not from the hole, but from the photons that have been bent and focused by the extreme curvature of space-time, forming a ring of fire that marks the outer boundary of the abyss. When the image was finally revealed to the world in the year 2022, it presented a golden ring of light surrounding a shadow of pure nothingness. This was the first direct visual evidence of the monster at our center, a cosmic eye looking back at humanity from across the vastness of the void. The ring was not uniform. It was brighter on one side, a signature of the relativistic effects caused by the plasma of the accretion disk spinning toward us at nearly the speed of light. The central dark region was the shadow of the event horizon itself, the place where the light of the universe goes to die. To look upon this image was to see the very edge of reality, the point where the physical world ends and the unknown begins. This achievement stands as a profound triumph for a fragile biological species inhabiting a tiny blue rock in the galactic suburbs. That a collection of primates, evolved to survive on the African savanna, could develop the mathematics, the technology, and the global unity to visualize an object located 26,000 light-years away is a testament to the power of the human spirit. We used the very rotation of our planet to sharpen our gaze, turning the Earth into a lens to peer into the heart of the monster. The image of Sagittarius A star is more than just a scientific data point. It is a mirror that reflects our own capacity for wonder and our relentless drive to understand the mysteries of the dark. As the scientists analyzed the golden ring, they found that it perfectly matched the predictions laid down by Albert Einstein over a century ago. The shadow was the exact size and shape required by the laws of general relativity, confirming once again that the universe operates according to an elegant mathematical logic. The monster was no longer a theoretical ghost or a mathematical scar. It was a visible physical presence, an anchor of light and shadow that defines our place in the cosmos. We had looked into the eye of the Titan, and in doing so we had proven that even the most profound darkness cannot remain hidden from the light of human inquiry. The capture of this shadow marked the end of one era of discovery and the beginning of another, as we now possess the tools to watch the very fabric of spacetime vibrate under the influence of the abyss. The passage of time, as we understand it, is but a fleeting flicker compared to the ultimate lifespan of the central Titan. Even the most formidable monsters are subject to the slow, agonizing decay of the cosmos, a process that ensures nothing, not even the anchors of galaxies, can endure forever. In the 1970s, the physicist Stephen Hawking proposed that black holes are not truly black, but leak a faint ghostly glow of radiation into the void. This process, a subtle dance of quantum mechanics at the very edge of the event horizon, ensures that Sagittarius I star is slowly, imperceptibly bleeding away its mass. In the vacuum of space, pairs of virtual particles are constantly winking into and out of existence, born from the fluctuations of the quantum field. Near the abyss, the immense gravitational gradient can tear these pairs apart before they can annihilate. One half of the pair may fall into the dark, while the other escapes into the universe as a real particle. To an outside observer, it appears as if the black hole has emitted a particle, carrying with it a tiny portion of the Titan's energy and mass. The rate of this evaporation is so infinitesimal that for the current age of the universe, it is entirely negligible, masked by the vast amounts of matter and radiation the black hole consumes. However, as the eons stretch into durations that defy the naming conventions of human language, trillions of years, this steady leak becomes the dominant force in the galaxy. We look toward a far future where the last of the stars have long since exhausted their nuclear fuel and collapsed into cold, dark remnants. The brilliant meadows of the Milky Way will fade into a monochromatic gloom as the red dwarfs, the longest lived of the suns, eventually cool into black dwarfs, frozen, silent spheres of diamond and iron that emit no light. The nebulae will disperse, and the vibrant gas clouds will be swept away or consumed. In this dark era, the universe becomes a graveyard of light, and the black holes remain as the final, lonely tombstones marking the sites where galaxies once flourished. Sagittarius A star will endure long after the memory of the Earth, and the Sun has vanished into the entropic haze. For a period of time spanning 10 to the power of 80 or even 10 to the power of 100 years, the monster will sit in the absolute dark, the sole occupant of a dead galactic core. It will continue its slow, rhythmic breathing of Hawking radiation, shrinking by a fraction of a millimeter every billion years. As it loses mass, the temperature of the black hole paradoxically begins to rise. A black hole of 4 million solar masses is currently colder than the cosmic microwave background, but as it dwindles to the mass of a planet, then a mountain, and finally to the mass of a single grain of sand, it begins to glow with a feverish, lethal intensity. The final moments of the Titan are not a slow fading, but a violent surrender to the laws of thermodynamics. In a final, silent flash of high-energy gamma rays, the last of its mass is converted back into light, a terminal scream that echoes across a universe that is no longer capable of hearing it. What remains after this final evaporation is a cold, empty vacuum, a state of maximum entropy where the very concepts of structure and information have ceased to exist. The disappearance of the central monster marks the final chapter in the history of our galactic home. The space that once hummed with the frantic motion of 100 billion stars and the powerful governance of the abyss is reduced to a featureless void, populated only by stray photons of immense wavelength, stretching out forever into the infinite night. This is the final silence of the cosmos, a peace that is absolute and eternal, where no record remains of the beauty, the violence, or the wonder that once defined the heart of the Milky Way. The fate of the monster is the fate of all things, a journey from the chaotic heat of creation to the ultimate peaceful stillness of the vacuum. This era of evaporation represents the ultimate victory of time over gravity. The massive structures that once dictated the movement of entire galaxies are unmade, particle by particle, until the fabric of space-time is smoothed out, and the last echoes of the Big Bang have been stretched into nothingness. The Titan at the centre of our galaxy, which today seems so permanent and unyielding, is revealed to be a temporary phenomenon, a passing ripple in the long history of the universe. Yet, even in its slow decay, the black hole poses one final, haunting question that challenges our understanding of reality. As it leaks its mass into the void, we must ask what becomes of the information it has gathered over its long life. Does the story of our galaxy, the history of every star it has consumed and every light beam it has bent, vanish along with the Titan, or is it preserved in some ghostly form within the radiation that remains? This information paradox is the final mystery of the abyss, a riddle that persists even as the lights of the universe go out one by one. The final mystery of the abyss lies not in its hunger, but in its memory. As we contemplate the slow evaporation of Sagittarius A star, we are forced to confront a haunting conflict between the two great pillars of human understanding. According to the laws of general relativity, the central Titan is a cosmic eraser, a place where matter and its history are crushed into a singularity and removed from the observable world. Yet the principles of quantum mechanics insist on a different truth, that information, the fundamental blueprint of every atom and every photon, can never be truly destroyed. If a book is burned, its contents are not lost to the universe. They are merely transformed into smoke, ash, and heat, and a sufficiently powerful intellect could, in theory, reconstruct the pages from the chaotic dance of the embers. But if a black hole consumes the story of a star and then vanishes through Hawking radiation, the universe faces a crisis of identity. If the past can be deleted, then the very foundations of cause and effect crumble into nonsense. This tension has given rise to a profound reimagining of the event horizon. It is no longer seen as a mere shadow or a point of no return, but as a holographic library, a two-dimensional surface that encodes the entire three-dimensional reality of everything the monster has ever swallowed. As a star or a gas cloud approaches the brink, it does not simply disappear. Instead, its information, the spin of its electrons, the arrangement of its nuclei, the very essence of its existence, is smeared across the surface of the event horizon. Like a cosmic tapestry woven from the threads of fallen suns, the dark skin of the black hole becomes a ledger of the galaxy's history. The three-dimensional volume of the object is translated into a complex, two-dimensional interference pattern, much like a hologram on a credit card that contains the depth and detail of a three-dimensional image. In this view, the black hole is not the destroyer of worlds, but the ultimate archivist of the cosmos. Every atom that has ever crossed the threshold of Sagittarius A star, from the first hydrogen clouds of the early universe to the stray planets of the distant future, has its signature etched onto the dark surface. The surface area of the event horizon is measured in units so small they defy the imagination. Planck units, the fundamental pixels of reality, each one a tiny bit of information. As the monster grows, its surface area expands to accommodate the new data, ensuring that the ledger is never full. The Titan at the heart of our home is revealed as a guardian of memory, holding the records of the Milky Way in a vault of gravity that is shielded from the ravages of time. The philosophical implications of this holographic reality are staggering. If the information of a star is preserved on the surface of the black hole, then the three-dimensional world we inhabit may be nothing more than a projection, a shadow cast by the data residing on the boundaries of the universe. We find ourselves living in a reality that remembers everything it loses, a cosmos where the past is never truly gone, but merely stored in a different form. This offers a sense of permanence to the fleeting lives of the stars. The suns that have been torn asunder by the tidal forces of the core are not forgotten. Their stories are written in the geometry of the abyss, preserved in a state of eternal frozen transition. However, the question of the evaporation remains. As the black hole leaks its mass over trillions of years, what happens to the library? Some scientists propose that the Hawking radiation itself carries the information back out into the universe, encoded in the subtle correlations of the escaping particles. In this scenario, the story of the galaxy is eventually whispered back into the void, a ghostly retelling of everything that was once lost. Others suggest that as the black hole shrinks to a microscopic point, it leaves behind a permanent remnant, a tiny, heavy seed that contains the entire history of 100 billion suns. The universe becomes a place that never forgets, an infinite archive where every event, no matter how small, is recorded in the fabric of space-time. Conversely, if the information is truly lost in the final flash of evaporation, we live in a universe that eventually forgets everything it ever was. The silence of the final vacuum would be total, a state where not even the ghost of a memory remains. This struggle between memory and oblivion is the true drama of the black hole. Sagittarius A star sits at the centre of this conflict, a heavy, silent witness to the passage of eons. It is more than a physical object. It is a manifestation of the universe's attempt to reconcile its own history. By looking into the dark heart of the galaxy, we are looking into a mirror that reflects the ultimate fate of information itself. We are the children of a galaxy that has spent billions of years writing its story on the surface of a monster, and our own existence is a brief chapter in a ledger that may or may not endure until the end of time. The realization that the universe is governed by an elegant and internal logic provides a sense of profound humility to the human endeavour. This humility is born from the confrontation between the fragile, finite nature of the human mind and the mathematical perfection of the cosmos. Over 100 years before the first radio wave was captured from the galactic core, and long before we possessed the tools to see through the curtains of dust, the mind of a single man had already mapped the geometry of the abyss. Albert Einstein, working with little more than pen, paper, and the relentless force of his own intuition, derived the equations of general relativity that would eventually define the shape of the shadow at the centre of our world. It is a staggering testament to the power of reason that a biological species, confined to a single planet, could use the language of mathematics to predict the behaviour of an object 4 million times heavier than the Sun, located 26,000 light-years away. When the image of Sagittarius A star was finally revealed, it was not merely a triumph of engineering, but a confirmation of this ancient mathematical prophecy. The golden ring of light, distorted and bent by the immense curvature of space-time, matched the predictions of the field equations with a precision that borders on the miraculous. The shadow was not an irregular or chaotic smudge. It was a perfect dark circle, exactly as the math had dictated a century prior. This resonance between the symbols written on a chalkboard in 1915 and the physical reality of a supermassive black hole suggests that the universe is not a collection of random accidents, but a structured masterpiece of geometry. To look upon the shadow is to realize that our thoughts, when guided by the rigors of science, can touch the very fabric of the infinite. This connection between the human scale and the galactic scale is deeper than mere observation. It is a matter of biological heritage. We are the children of the stars that orbit this dark sun. Every atom of carbon in our cells, every iron atom in our blood, and every calcium atom in our bones was forged in the nuclear furnaces of ancient suns that lived and died within the gravitational embrace of the Milky Way. Our very existence is a byproduct of the stability provided by the central monster. Sagittarius A star is the heavyweight at the centre of the cosmic carousel, the anchor that prevents the hundreds of billions of stars in our galaxy from flying apart into the lonely intergalactic void. Without this central titan to hold the galactic disk together, the dense meadows of stars would have dispersed eons ago, and the conditions necessary for the birth of our solar system might never have emerged. The scale of this relationship is a study in profound contrasts. A human life spans less than a century, a mere heartbeat in the life of the galaxy. The star S2 completes a single orbit around the black hole in 16 years, a duration that represents a significant portion of a human career, yet is but a fleeting moment for the titan it circles. The black hole itself has sat at the centre of our home for over 10 billion years, a silent witness to the entire history of the Milky Way. We are microscopic inhabitants of macroscopic machine, yet we are the only part of that machine that has developed the capacity to understand how it works. The monster at the centre is the foundation of our home, the silent governor of our destiny, and the reason we have a skieful of stars to gaze upon. There is a deep irony in the fact that the most destructive force in the universe is also the primary architect of our stability. We often think of black holes as cosmic villains, voids that consume everything they touch, yet Sagittarius A star is the very reason the Milky Way possesses its elegant spiral structure. It is the sculptor of the heavens, carving the paths of 100 billion suns and ensuring that the galaxy remains a coherent, organized whole. Our existence on this pale blue dot is tethered to that central shadow by an invisible thread of gravity that has remained unbroken for billions of years. We are part of a grand celestial hierarchy, where the movements of the smallest atoms are ultimately linked to the heavy, silent presence of the Titan in the dark. Reflecting on this reality brings a sense of peace, rather than terror. To understand that we are integrated into the architecture of the cosmos is to realize that we are not accidental intruders in a hostile void, but a natural expression of the universe's own complexity. The mathematical perfection of the black hole is not a cold or distant truth. It is the blueprint of our own sanctuary. We have looked into the dark heart of the galaxy and found not just a monster, but a mirror, a reflection of our own capacity to reach across the light years with the power of our minds. The humility we feel in the face of such scale is the beginning of wisdom. a reminder that we are a small but vital part of a story that began with a flash of light and will end in the quiet stillness of the vacuum. As we turn our gaze back to our own world, we carry with us the knowledge that the shadow at the centre is not a hole in the universe, but the very pillar upon which our reality is built. The pale blue dot of Earth remains a fragile sanctuary, a tiny island of complexity floating in a sea of radiation and vacuum. From our distant vantage point, 26,000 light-years from the galactic core, the Milky Way appears as a grand, terrifying and beautiful symphony of light and shadow. We are the listeners of this celestial music, perched on a world that orbits a modest yellow sun, which in turn follows the rhythmic pull of the dark titan at the centre. This relationship defines the very nature of our existence. We are not separate from the abyss, but are part of its long, gravity-bound reach. The monster at the heart of the galaxy is not a villain in the story of the universe, but a guardian of the mystery, a silent sentinel that marks the boundary between the known and the infinite. It is the anchor of our home, the heavy heart that keeps the spinning meadows of stars from dissolving into the featureless dark of the intergalactic void. The journey of the cosmos is a long and winding arc, stretching from the chaotic, white-hot heat of creation nearly 14 billion years ago to the ultimate peaceful stillness of the vacuum. In the beginning, there was only the screaming energy of the first moments, a period where space and time were forged in a furnace of infinite density. As the universe expanded and cooled, the first stars ignited, and the first black holes began their long work of gathering the wandering gas into the majestic spirals we see today. Sagittarius A star was born from this primordial hunger, growing alongside the Milky Way, acting as the sculptor that shaped the destiny of our galactic neighbourhood. It has watched as generations of suns were born and died, as planets formed from the debris of stellar explosions, and as a small, inquisitive species on one of those planets developed the capacity to look back and name the force that holds them in its grip. In this context, the black hole is revealed as the ultimate guardian of the mystery. It represents the limit of what we can ever know, a place where the light of human inquiry finally meets a barrier that it cannot cross. Yet, this boundary is not a wall of despair, but an invitation to wonder. To look into the mouth of the abyss is to recognize our own insignificance, but it is also to celebrate our incredible capacity for understanding. We are a biological species made of the dust of dead stars, yet we have used the laws of physics to visualize a shadow located at the center of 100 billion suns. We have turned the entire planet into a telescope to see the unseeable, proving that the mind can reach places where the body can never go. The terror of the abyss is balanced by the beauty of the discovery, a reminder that we are part of a universe that is both vast and deeply interconnected. The symphony of the Milky Way continues its slow, majestic rotation, a dance of light and shadow that has played out for eons and will continue long after we are gone. The stars of the core will continue their frantic, high-speed choreography around the invisible Titan, and the accretion disk will continue to glow with the feverish intensity of 1,000 suns. We live in a brief and brilliant moment of cosmic history, a time when the monster is sleeping and the stars are bright. This moment of grace is our home, a sanctuary provided by the very gravity that could one day reclaim us. The pale blue dot is not a lonely accident, but a vital part of a grand architecture, a single note in a composition that spans the entire breadth of space and time. As we look toward the far future, we see a universe that will eventually grow cold and dark, a graveyard of light where only the black holes remain as the final witnesses to the story of existence. But even in that final silence, the legacy of the Milky Way will endure, encoded on the dark surfaces of the titans that once governed the stars. The information paradox suggests that nothing is ever truly lost, that the history of every atom and every heartbeat is preserved in the geometry of the abyss. The monster is the archivist of the cosmos, the keeper of the records, holding the memory of our galaxy in a vault of time and gravity. This is the final, comforting reality of the dark. It is not a void of nothingness, but a vessel of everything that ever was. The capacity for wonder is the greatest gift of our species, the light that allows us to navigate the shadows of the unknown. Even as we confront the scary reality of the monster at the heart of our galaxy, we find not just terror, but the anchor of our existence. The abyss is the foundation upon which the beauty of the heavens is built, the dark sun that allows the bright suns to shine. To understand Sagittarius A star is to understand the true nature of the universe, a place of extreme power and delicate balance, where the most profound darkness is the source of the most enduring stability. We turn our gaze back to the pale blue dot with a renewed sense of humility and awe, carrying with us the knowledge that we are the children of the stars, the witnesses to the shadow, and the temporary residents of a beautiful, terrifying, and eternal home. The monster remains in the dark, a silent guardian of the mystery, reminding us that there is always something greater than ourselves lurking in the shadows of the magnificent shimmering void.